Welcome folks, we're live with a donor vehicle, in this case a 2016 Hyundai Ascent that I've not worked on or seen before. I thought it would be helpful to actually show you a brief demonstration of this tool in action. So this is the current Neutronics Refrigerant Analyzer. This is the Legend series, and this is the third in the series that I have actually used firsthand in workshop land, and I find them extremely accurate and very, very valuable in a workshop situation. This latest tool is battery operated, rechargeable internal battery, so no need to connect to a power source, be that the donor vehicle or to an external power source. I've also found that the engineering that goes into the analytics in these machines to be incredibly reliable and also repeatable. So once you understand how they work, you can put your trust in the information that you get from these. So this particular machine is really good if you don't use it every hour of the day, because the screen will actually give you step-by-step instructions of what you are to do next to get an accurate reading of the vehicle. With the machine, you get a variety of adapters and hoses. The one we're using today is a traditional low side coupler that we're all familiar with. It comes with a supply hose with a bayonet fitting on the other end. And importantly, this particular evolution of the Legend machine has an external inline oil catch filter, which you can see has done its job on a previous vehicle. So that vehicle had some oil and dye and it's caught that and it hasn't gone through the filter. This particular machine does all of the analysis on refrigerant that is in vapor form. We do not want to analyze liquid refrigerant or feed liquid refrigerant into the machine. Okay, there are 4 stages to the refrigerant analysis. Each of those takes a little less than 30 seconds. So from start to finish, without all the talk, you can do a very accurate refrigerant analysis on your sample in less than 2 minutes. Let's power the machine up. Stage 1. The initial stage is a self-test stage. It's checking the software and firmware, and it will display the actual software and firmware values on the screen. And if everything is okay and it's happy with the circuitry and the resistance value through the actual sensor that it's going to heat, then it will come up with the screen lit and it will print Legend series on the printer to say we're good to go. After that, we get the option to hit next. So let's progress to stage 2. This is the warm-up stage, and typical of software, we get a progress bar that shows that the tool is going through a warm-up where it's bringing the sensors up to the temperature that it needs. Again, this takes generally less than 30 seconds. Okay, just about at the end of the warm-up stage now. In this second phase, we're given the option to choose the refrigerant we think we are looking for. This particular machine is capable of analysing R12, R134A, R1234YF, also detecting flammable refrigerants such as hydrocarbons and determining the amount of air content that might be in the system, which can be linked to high moisture content. So in this particular case, I'm going to select R134A because we believe that's what this system should contain. Now importantly, making a choice here helps the machine know where to start with the algorithms internally, but ultimately it will look for all refrigerants when it breaks down that chemical makeup of the sample charge. So let's choose R134A. The instructions are quite clear on the screen. It says connect hose to analyzer only. So up until now, the supply or source hose has not been connected. So to connect to the analyzer only is important for calibration. The plastic quarter turn bayonet fitting attaches straight to the back, just like so, and then we'll hit start. And we're now in the third phase, or the calibration phase. You may hear the internal pump or purge motor running as it's going through the calibration. And the one thing I've learned over the years with any of these refrigerant analysis tools is to do the calibration in the vicinity of where you are testing the sample. Don't calibrate the tool in the safety of your air-conditioned office that's remote from the workshop. Calibrate it where you're going to do the sample, and you can be guaranteed of an accurate reading. We're on the last stage now, and the instructions clearly say connect to source. Now in this particular test, we're testing the refrigerant sample in the vehicle, so our source will be the low side coupler on the suction line. But this is also capable of testing your refrigerant cylinders. So I'm going to take my coupler, which is typical of a R134A low side coupler, locate the low side port, wind that in to depress the Schrader valve, and then we'll choose test. And again, this process takes a little less than 30 seconds for it to do its job. You get the progress bar and it indicates on the screen that the test is taking place. Okay, the testing process has just completed. We heard the 3 beeps, and we're now giving instructions to disconnect from the source. So I will wind out my coupler from the low side access port and disconnect from the source. Now when I go to display the results, we will see a table that will give us a breakdown of the refrigerant makeup of this system. Also, it will give us a background colour that will indicate at a quick glance how pure that refrigerant sample has tested to be. So if we have mostly R134A with perhaps a little bit of air, we will get a green background because that is generally considered a safe charge for the operator or the technician. As that charge gets more contaminated, or indeed has elements of flammability detected, the background of the screen will change to orange and red. So it's a very quick visual indicator that there should be cause for concern without even having to study the breakdown of the table. So let's press results and we'll see what we can find. Okay, interesting and fairly typical. Let's have a look. Okay, looking at the results as it's been displayed, we can see firstly the background I was just referring to is green, meaning we have reasonably low level of contamination and we have no flammable substances detected. You'll see the top line R134A, which is what we were expecting, has shown as 100%. That means 100% R134A. There is no mixture of refrigerant in this sample. Indeed, if we go to the next line where we're displaying other substances, R12, 1234YF, R22, you'll see that they all read 0%. Hydrocarbons or flammable refrigerant, 0%. Unknown substances, 0%. But here's the one I'm interested in, air content, 10.6. That's extremely high, and that is a cause for concern. Air content carries moisture, it displaces refrigerant, causes excessive head pressures, and gives you similar symptoms to a system overcharge. Now that I've got the results finalised, I can remove the source hose from the machine. And you can see I've got an option here to print. If I press the print button, this has an internal printer, and it will print those results for me.